Greetings, STEM scholars. Welcome to the video on slope, aka not so typical slope. Why did I choose that title? Well, first of all, our first example deals with Romeo's, and everybody that I know really likes Romeo's cheese dip. So I thought if we're going to learn math, why not do it with some fun food? So the other reason I called it nacho typical is because a lot of the slope things you learned in middle school we'll be using, but they're going to have a slightly different twist. Pretty much everything we do for slope in this class will have units or a meaning attached, and it won't just be random numbers that we're kind of dropping out of the sky. Okay, so first things first on your worksheet, I would always get the date. You'll get a lot of handouts in here, so try to organize this by putting the date in there. Okay, I just put the date. You'll be most likely watching this video. What we're going to do with slope is first talk about what it is. So when we look at your slope formula, over on the right, there's a couple different ways to write it. I want to have you start by using probably the most common one, which says you're going to take the y value, I'll call it y sub 2. The 2 doesn't mean it's squared. The 2 just means it's like the second y value. Minus y1, which, again, that's a subscript, so it's written kind of below the y. And then in the denominator, we'll have x2 minus x1. All right, so some people, if they don't remember that formula, if they remember words better, might say it's the change in the change in y divided by the change in x. That's another way to think about that. Okay. Another way to express that same thing is with this little triangle, and that you read that as delta y. I'll put that in quotes here. Delta y. Delta is the Greek letter for D. Delta y. And when you see triangle in math, like, or in really any engineering or science field, the triangle means change. And so it's delta y, change in y, over delta x, change in x. Again, it's all mean the same thing. It's just different ways of expressing it. You just got to find a way that makes sense. So slope is really just a rate of change. So down below, we'll fill that in. It's a rate of change. And I also put another visual off to the side to recall that the y values on our ordered pairs are vertical and the x values are horizontal. And then when we write our ordered pairs, we'll always write x comma y. Okay, so if we look at this graph here, it kind of tells a story. And the story this one is telling is that as more people show up at your table at Romeo's, I wish it worked this way. Wouldn't it be awesome? But as more people show up at your table at Romeo's, this graph is saying that you will get more chips in the basket. And so what we want to figure out is how much is it changing. In other words, as people show up, how many more chips are we getting every time a new person comes to your table? So that's basically your slope. The slope is the rate at which the y values, in this case the chips, are changing in relation to the people at the table. Okay, so here's what I'm going to have you do. We're going to pick 2 points on this line. You can pick any points on the line, but I like to look at the numbers on the x-axis and trace them up. And you can kind of see how this one, no, don't circle that one. That one kind of looks like it crosses. Don't write this yet, I'm just trying to show you. It looks like it crosses right in between 2 squares. I don't like to pick those ones. They're harder to work with. So I'm going to find a spot like this 4 right here. That seems to cross, the line seems to cross the grid system. If you track your eyes over, right at the number 70 and right at the number 4. And it doesn't have to, you don't have to pick points that are like perfectly aligned, but I feel like when you do, it makes it a little bit easier and cleaner. So I'm going to write that ordered pair right next to it. I want you to do the same. How far over did we go? Well, that's 4. And the unit is people. I want you to put your unit in there. Everything we do in here will have units for the science and most of the math. And then if you track it up, this is 70, and then the unit is chips. So 4 people, comma, 70 chips. In other words, if 4 people are at my table at Romeo's, they're going to bring 70 chips. And then we're just going to track that along and try to find another spot. Looks like even here, this looks pretty good. If you track it down, that matches up with 2 people. And when 2 people are at the table, if we track it over, it falls right in between 40 and 50. So I'm going to say that's about 45. So that's 45, and the unit is chips. All right, those are the ordered pairs we're going to use. So I'm going to write those down below. I'll transfer them down here. So we had 4 people, 70 chips. And when 2 people were at our table, oops, I don't need that E, do I? There we go. 2 people, we had, was it 40? 45 chips. Okay, so I think it helps to label X's and Y's on my ordered pair. So I'm going to put X and Y. I'm going to do the same thing down here. X and Y. You can call these the 1s and the second ones the 2s, or vice versa. It really doesn't matter. You just have to be consistent. Some people like to say, you know what, these came later in the graph, so I'm going to call those the 2s, and I'm going to call these the 1s. It doesn't matter. You just got to decide. All right, so I'm going to highlight the X's in one color with the unit. These are my X's. I'll do the Y's in another color. And notice up here, see how the Y's are in yellow and the X's are in green. All right, so that's how we're gonna set this up. I'm gonna say M equals, M is the abbreviation for slope. Okay, and let's look back at our formula. The formula says take the Y values on the top of the fraction or in the numerator and subtract them. So here, these are my Y values, 70 chips and 45 chips. So we're going to do 70 chips, don't forget the unit, 70 chips minus the other Y value, 45 chips. The units also help because whatever you're subtracting should be the same unit. We wouldn't take 70 chips minus 40 people. That doesn't make sense. All right, so I took 70 minus 45. I took the 2's minus the 1's. And then look at the X's. The X's in the denominator, we're supposed to do the same thing. So take the second X minus the first X. So my second X, or the ones I'm calling 2, is 4 people minus 2 people. Oops. Ah, that's all right. There we go. 4 people minus 2 people. Forgive the handwriting. Sorry, it's not easy to write on the screen when I'm typing it with my keyboard. There we go. All right, notice the unit matched. Everything matches up. So the green numbers, the X's go on bottom. The Y's, I always say the Y's rise to the top. The Y's go on top. So let's just simplify. So M equals 70 minus 45 is 25. And the unit is chips. And then in the denominator, it's 4 minus 2, which is 2 people. All right, and then what I'm going to have you do is either you can do this mentally or with a calculator. You're going to divide this out. All right, and if we divide that out, 25 divided by 2 is 12.5. Notice it's a positive number. And we're not going to leave it like that. We need the unit. So 12.5 chips per people. And I'm going to actually put per person. People sounds weird. Chips per person. So that means as another person shows up, after one extra person shows up at my table, we're getting about 12 and a half more chips. Let's see if that makes sense. So here, 2 people had 45. So by the time 3 people show up, we should be about 12 and a half bigger. So 12 and a half plus 45 is about 67.5. Let's see if that matches. Yeah, I'd say that's pretty much, or I'm sorry, 57.5. If you look right here and follow it over, I'd say that's right at about 57.5. So there's your slope, okay? What I'd like you to do is on the back side, we want you to try this example. The graph is set up already for you, and if you look down below, we kind of wrote the steps down with more detail. I want you to make sure you include your units. So even here, units should be listed. Same thing on part C. Part C, you should have units. And then when you're done, we want you to bring it up to a teacher to get some feedback. All right, good luck. Raise your hand after you've attempted or at least started to use the front side as a reference.